My name is B. Raghu. I am studying in BTech first year. Today topic is Maclaurin's theorem. Introduction to Maclaurin series. The Maclaurin series is a special case of the Taylor theorem expanded at x is equal to 0. Allows us to approximate functions using n primitive sum of polynomial terms. Used widely in calculus to analyze the behavior of functions 0. Next about define of Maclaurin series. The Maclaurin series for a function f of x is given by the sum n is equal to 0 infinity involves derivatives of the function evaluated 0. The series provides as a polynomial approximation that converts to the function under certain conditions. Next about derivation of Maclaurin's series. The series is derived by expanding the functions into its Taylor series. At x is equal to 0, discuss the concept of derivatives to match the functions behavior at 0. Each term in the series corresponds to derivative of the function at 0, scale by factorials. Next about conditions for convergence. The Maclaurin series converts to the function if the function is analytic at 0. Convergence depends on the radius of convergence with values for different functions. For some functions, the series converges only with a certain interval around 0. Next about common functions and their Maclaurin series. The exponential function e power x has a Maclaurin series of sum n is equal to 0 infinity fractions. The sine function sin x is expanded as sum n is equal to 0 infinity fraction minus 1 n 2n plus 1. The cosine function cos x has a series sum of n is equal to 0 infinity fractions. About next step. Examples of Maclaurin series of for functions. The function f of x is equal to 1 plus x expanded to some infinity fractions n plus 1. Geometric series fractions 1 minus x has a Maclaurin expressions of sum n is equal to 0 infinity for mod x less than 1. These examples demonstrate how series can approximate functions with specific domains. Next about using Maclaurin series for approximation. Maclaurin series can be translated to provide polynomial approximations of functions. These approximations are usually Maclaurins where exit values are different to compute. The degree of the polynomial determines the occurs of the approximation near 0. Applications of Maclaurin series. Maclaurin series are used in physics to analyze accelerations and wave phenomena. Engineering apply them in signal processing and control system for system analysis. There are essential numerical methods for solving different equations and optimization problems. Next about limitations of Maclaurin series. The series may not convert for all values of especially from 0. Non-Atlantic function, the series might average not response in the function accurately. Turns the series introductions approximation errors that need to be managed carefully. Next about comparing Maclaurin and Taylor series. The Maclaurin series in Taylor's series expanded special at x is equal to 0. Taylor series can be expanded at any point not 0 offering more flexibility. Both series are tools for approximing functions but differ in the point of expansion. Summary of key concepts. Maclaurin series provided polynomial approximations of functions near zero. This series involves derivatives evaluated as scaled by factorial terms. Understanding convergence and limitation is crucial for efficient application. Reference Straight 2015 Calculus Early Translation Learning. Thank you.